going to look at now doing our plan for the experiment. This is quite a big section of our experiment, so make sure there's a lot of detail that we specifically need. So some of the things that we specifically need is we need to know what our experimental units are. So that means the people who are going to be actually doing the experiment. We need to know what your treatment group is and your control group is. Okay. We need to know what your response variable it is. So what is it that you're measuring and what units. So how are you going to measure it, what instruments you're going to use, and what exactly it is. Then we need to specifically talk about our random allocation, because this is what makes it an experiment, not an observational study, is being able to randomly allocate our treatments to the experimental units. So we also need to talk about how we're going to collect the data, how we're going to record the data, and looking at what sources of variation might we have in our experiment itself, because the key idea here is that we want all conditions of the experiment to be exactly the same for both control group and treatment groups, apart from the one variable that we are actually testing. Okay, we want everything else to be controlled, because that means the results that we get, we can see, are only due to the one thing that we're testing and not possibly due to lots of other different things. So the first idea that I want to talk to you about is this idea of a control group. So a control group can be one of two things. Either it can be the group that does not get any treatment, or it gets an existing treatment. So for example, if I'm trying to test a new cancer drug, ethically I cannot give no treatment to a group of cancer patients. I have to give a group of cancer patients the current treatment regime for that particular cancer, and therefore that is your control group, is just receiving what the standard of care is, and therefore the treatment group would be the ones that receive the new drug. We could also have a group that essentially gets nothing, and this is called the placebo effect. We know that about 30% of people feel better just by going to the doctor and receiving a sugar pill. So they've done experiments to prove this, and it's called a placebo effect. So just by going to the doctor, talking about the doctor, and having a pill made of sugar that looks exactly the same as any other pill but doesn't actually do anything, has no chemicals that do make a difference, 30% of us will feel better just for having gone through that process. So there's a psychological component to it as well. So that's why often they'll set up drug trials, will be all the patients get a drug, but some of the drugs are actually sugar pills and some of them are the new medication. So therefore the control group would be just getting the sugar pill, or not receiving any treatment, but just getting essentially nothing. Okay, so we want to make sure that all of those groups are similar in terms of their ethnicities, their gender, their left-handedness, right-handedness, any factor that we can think of. We want the groups to be the same, apart from the thing that we're actually going to be testing on them. Okay, so that moves us now on to experimental design principles. So these are some of the things that we've got to think about. We need to have controlled conditions. So you can see in this little picture here with the monkey, we want to keep everything the same except for what it is that we're testing. So A and B, there is a monkey sitting on the pink seat that is exactly the same in both of those situations. The first situation, the control is nothing. The second situation is somebody doing the experiment itself. Okay, so that's what we're trying to do, is we're trying to control all of those conditions. So it could be the lighting levels, the volume levels if we're playing music. It could be the atmosphere. It could be if I'm driving a car, that we're driving the same car. Whatever the test is, we want conditions to be the same. We've also got something called blinding and double blinding. It doesn't always happen, but often we try to if at all possible, because we don't want there to be an effect just because people know what's going on. So if I know that I'm doing an experiment to test if music makes a difference to my learning, and if I know that beforehand, then I might be actively trying to change my reactions because I think that music makes a difference. And what we want to be able to do is test people regardless of whether they know. So we don't want them to know, and we want to actually see, is there a difference in learning due to music? And we want to be able to just, without people knowing whether they're getting music or no music, we want to just randomly allocate that. So a single blind is when it's only the researcher that knows the participants group. So a single blind, the actual patients or the experimental units don't know anything. They don't know whether they're getting a control or a treatment, or they don't know which one they're getting. They don't know if they're getting the sugar pill or they're getting the actual new drug. The doctor or the person in charge does know that though, okay? Whereas if we're talking about a double blind, that means the doctor that's administering the pills and the patients themselves don't know. So the experimental units and the person that's actually doing the experiment does not know which one they're getting. And so that means that the doctor or the person in charge of running the experiment can't give off subtle body cues to let people know which one they're doing. So most of the time the one that we're going to be dealing with is we're going to try to set up a single blind experiment. A double blind experiment is a lot more complex, but that is the gold standard, and when we actually have to do this for real in industry. So then we get to our next factor we've got to think about is randomization. So we have to split people up into two groups, a control group and the experimental or the treatment group. And we need to split people up and decide which group they go in based on a random method. So we want to try and have a big enough sample size, and we want to make sure that they are being randomly chosen, that it's not all of my friends who are sporty in one group versus all of the other people who are not sporty in another group. We want the characteristics in both to be a mix or representative of each other. Another factor we need to think about is variability. So we want to minimize the variation. Okay, we want to have as low variability as possible, and that's where we come into controlling all the things that we can possibly control, so that the only variation left is the variation due to the experiment itself, not due to other factors. And the last piece here is on replication. Okay, if we can get, this is not always going to be possible, but when it is possible, it's quite good to be able to do the test several times for each person doing the experiment to be able to get a replication of those results. Okay, and that gives us much more information about the variation. So let's just have a look at this random allocation in a little bit more detail. So when we're comparing two groups, we want to have all of these different things, all the characteristics to be the same. So how do we do that? Well, the simplest way is to have a piece of paper, or group piece of paper with either A or B written on it, and if a person, and then I have them all shuffled up. If a person receives an A, they're in group A. If they get a B, they're in group B. And then I decide, right, group A is my treatment or my control, and group B is the other one. So I could do it that way. I could also use a deck of cards. If they get a black card, that means they're in treatment group. If they get a red card, they're in the control group. I could toss a coin. If it's heads, that means. If it's tails, that means. So there's lots of different ways that you could do that. And there's a little example there of some instructions that I would give to do that. Okay, put 30 students, put 15 black cards representing group 1 and 15 red cards representing group 2, shuffle them up so they're randomly mixed, and that's important so that I know that you've identified how we're going to make them random. And then I give each student a card. If it's this, they do that. If it's this, they do that, and move them into the right groups. Okay. Another thing to think about is our sample size. Count data, we want to have usually at least 50. Measurement, the golden rule is at least 30. And this is talking about the sample sizes in each group. So when we actually come to do this experiment, it's not always going to be possible to get to this number. Sometimes it depends on how many students are actually there on that day. If we've only got 15 students in the class on that day, that's all we're going to do the experiment on. So this is what our goal is, if you like. We want to aim to get at least this much information. We may or may not actually get to that point, but that's what our goal is. Okay. Then we need to look at how we're going to record that data. So we're going to have one column of data, so we're going to set up a spreadsheet that has one column which tells us which group they are in, and one column which has the measurement that we make. So if it's their height or their weight or how far they could jump or whatever it is that we're measuring, one column with which group, and one column with what we're measuring. So if we're talking about look at our example now of our dominant league. So our experimental units, what are they going to be? Well, in this case, our experimental units are students in the stats class in 2016. So I've been quite specific about who that is. I've got to define my treatment variable. And remember what I'm doing now, sorry I should have said, is I'm just going back up to page 11, top of page 11, is these are the things I must have in my plan. So I'm just going through this list and making sure I've got all of those pieces there. Okay, so my treatment variable is my second thing. So my treatment is the group of students going to be standing on the non-dominant leg, and the control group is the group who will be standing on their dominant leg. So I've defined both of my groups. I've defined who's going to be what my treatment group is and what my control group is. I then need to define the response variable. So what's the response that we're going to check? So in this case, I'm measuring the length of time that they can stand on that leg, and I'm going to measure it using a stopwatch. So I'll see what tool I'm going to use, and I need the units. I'm going to be measuring it in seconds, and ideally I want to get students to repeat this twice. Okay, I don't know whether that would be possible, but that's what I'm going to aim to do. Then I need to describe the random allocation. So I'm going to decide how am I going to randomly allocate them. So I'm going to divide that. I'm going to take the sample size of how many people are in the class, divide it in half, and if a student gets an A or a B, then that I need to explain what that means. Okay, so here I've said I'm going to randomly shuffle them, and this is now talking about the blinding part. I'm not going to tell the students whether they're in the treatment group or the control group. Once they've been given a piece of paper that says A or B, then A will stay in the room while B goes outside. Then they'll swap over, and it won't be until after the experiment that they know whether they were the control or the experiment group. So for the purposes of this experiment, I'm going to make group A the treatment, and they will be standing on their non-dominant leg. When group B will be the control group, and I'll have them standing on their dominant leg. And then I'm explaining why I'm doing this, and this is good for our merit. I'm randomly allocating them because, and I'm giving an explanation of why I do that. Then I need to say, well, how am I going to collect my data? Well, I'm going to have a stopwatch on the whiteboard, and students, I'll need to give them some instructions so that they record the time that they were able to stand on their leg before they fell over, and they're going to write it on that same piece of paper with the A or the B written on it. And at the end, those students will give me those pieces of paper, and I'm going to record them, and I give an example of the table that I would use to record it on. The last piece that we need is looking at what factors are we going to control. So here's some things that I'm going to control. I'm going to make sure that the instructions are given clearly so that the students know to watch the stopwatch. Okay, we don't want them being distracted and talking to each other, and then a few seconds passes after they've stopped before they remember to look up at the screen and record the time. So I want them to be quite accurate with their timekeeping. I want to make sure that no one falls over and knocks over another person, so that means I'm going to make sure that they're standing at least an arm's length away from each other. And so you'll notice I'm saying, well, I think that they should do this because, and I'm giving the reason why. So I'm telling about why I'm going to control it. And that's what we want to see for our merits. And again, another third one there, I'm going to talk about how they hold their foot, so that everyone in the room is consistent in how they position their foot, so that we don't get any differences due to positioning of their foot. And that is our plan.